Hello all. What we want to do here is just look at some of the videos that have been posted and look at ways that we can tweak them, fine-tune them. I think the one thing we have to keep in mind is our target audience. For the past 2 years, many of these children will have had very little, if not no, classroom time with a teacher. And I don't want to castigate all teachers in government schools, but some of them, the education is really wanting. I can give you an example. I know of a family who send their children to a small private school in Waterfalls, and the teachers there are just trying to encourage the children to come for extra tuition. This is despite them paying private schools fees at a private school. So let's look at firstly introduction to algebra. There was the example of a plus a plus a equals 3a, which is fine. Now it was stated verbally that this is the same as 2 plus 2 plus 2 can be written as 3 multiplied by 2. But I really believe that we need to show that example so that the children are not only hearing it, but also seeing it. So it's very good, especially at the stage of introducing algebra, to link it up with arithmetic because they're familiar with arithmetic concepts. And all we're doing, basic algebra, is really doing arithmetic with letters. The other thing I felt that needed emphasis was, again, it was stated verbally, this is a term, and if you put two such terms together, then together they make up an expression. Again, this was stated, but I felt it needed to be written out. And before that, to explain what are like terms, what are unlike terms. So this is an expression because it has unlike terms that cannot be simplified any further. It is true you can get an expression with A's and B's, but you can simplify it down to an expression of a collection of A's, a collection of B's. I would do a video for addition and subtraction, and then I would do another one for multiplication and division. While we're on the addition and subtraction, there was the example given, and it was simplified to 2a plus 2b. What needs to be shown is that this can be rearranged. So that expression could be written in that form, and then we can put the A's together and the B's together, and then simplify it. Furthermore, when we have additions and subtractions, this particular example, the answer was actually given as 1a minus 1b, and you can see that's incorrect. So that in fact was an error that needs to be corrected. But I want to do something like this here. So I'm going to put it in this form. In fact, I'm going to make that the plus and this the minus. And show that when we rearrange it, the sign with the A comes with it. So I'm going to reorganize the order of these terms, and when I do that, the sign in front of the term comes with it. So then it becomes a plus 2b and a minus b. So to show that you can rearrange a collection of like and unlike terms, but when you do it, the sign goes with it. If I could go on to the multiplication and division, which I'm suggesting you do in a separate video, you had the example of a multiplied by a giving a squared. And again, I think it was said verbally, but I would have wanted you to show that if we have 4 multiplied by 4, we know that that can be written simplified to 4 squared and then get an answer afterwards. With a square, yeah, not much difference, but if you had something like this, we don't want to keep writing that out, and we say that that can be expressed as 4 to the power of 5. So show the arithmetic example there. Then when we came to division, the example of a cubed over a was given, and you talked about subtracting an a from the top. You were talking about the rules of indices. Now, if that's been covered, fine, not a problem. But I would begin by saying, well, what does a cubed mean? That's what it means. Divided by a, and show that these cancel to give you the result a squared. And that is why we can subtract the powers. Right. That is order of operation. Sorry, that is introduction to algebra. I'm going to go on to order of operations. The pyramid was given. Brackets, indices, division, multiplication, addition, subtraction. And it was stated that division and multiplication are on the same level, addition and subtraction on the same level, because they're the opposites of each other. That is good. It's good for the students to realize that division and multiplication are opposites of each other. Explain what the opposites mean. They undo each other. So if I take a number like 5 and multiply it by 6, I get 30. If I take that 30 now and divide it this time by 6, I get back to where I started from. So that's what we mean by opposites. They undo what the first one did. And the same for addition, subtraction. Show an example. But the other thing I'd like you to do is, why are they on the same level? Because we can reverse the order of these operations. So if you have something like 12 divided by 4 multiplied by 2, we know this can be written as 12 divided by 4 multiplied by 2. And now I can do my division first, giving me a 3, and then multiplying that out gives me 6. However, let's start there again. I could have done the multiplication first, giving me 24 divided by 4, and I get to the same answer, 6. So that is why they are on the same level. The other thing on this particular one that I'd ask you to be aware of, and it's a common mistake. I think a lot of us maths teachers make this mistake. You were talking about indices, and okay, so let's look at this here. And you said that implies that the base number, and this is what you call the base, is being multiplied by itself 3 times. Now that's not true. Let's look at it. This is what it means. The base number is being multiplied by itself twice. So what this means is you are taking 3 lots of the base numbers and multiplying them out. Like I said, it's a common error, but I think we need to be careful of that, because if a child catches on to what you're saying, it's the number of times the base number is being multiplied out, they're going to think, well, it must mean this. There's the base number being multiplied out 3 times, and that, of course, is wrong. So I'm going to stop that video there.